Hello students. So today we'll continue with Castigliano's theorem examples. Let us consider first example, a standard example. A simply supported beam of span L carries a concentrated load P at a distance A from left support. Using Castigliano's theorem, determine deflection under the point load. Let this be point load acting. So I have to, it is given that the point load is at a distance A from left support. So what I can assume is we can consider at B from right support. Let total span is L. Let this be point A, point B and point C. So I have to find deflection at C, delta C. So again same steps. So first step will be finding reactions. Summation of moments about A is equal to 0. Clockwise forces are positive. So what I can write, minus RB into L. Let this be RA. This be RB. Minus RB into L is equal to P into A. Minus RB into L plus P into A is equal to 0, or RB is equal to P into A by L. So similarly I can write summation of moments about B is equal to 0 about B. So minus RA into L plus P into B, minus RA into plus RA into L minus P into B is equal to 0, or I can write RA is equal to P into B divided by L, PB divided by L. So RP is PA by L, RA is PB by L. Now I'll put that in the tabular form. So let this be portion AC and BC, origin, limit, M, EI. Same thing. Now I have to consider the limits. So I have to consider limits such that whole beam is considered. For AC I am going to consider it like this, and for BC I will consider the limits like this. So we will write the values for AC. Origin is A, limits 0 to A, moment M, moment at this section. Forget this part of the beam, consider only this much. So moment at this section is RA into X. So P into B by L into X. P into B by L into X. Now here for this, origin is B, limit 0 to B. Again moment at this section RB into X. So P into A by L into X. These values are EI and EI same constant. Now first I will find out strain energy, then from that I will find out delta. So strain energy is given by integration of 0 to L M square by 2 EI dx. So I have to add for this beam and this beam together. So I can write here 0 to A PB by L into X whole bracket square divided by 2 EI dx plus 0 to B PA by L into X whole bracket square divided by 2 EI dx. So from this I will take 1 upon 2 EI constant, 1 upon 2 EI integration of 0 to L. I will simplify this bracket, P square B square X square by L square. into dx plus 1 upon 2 ei p square a square x square by l square, integration of 0 to b p square a square x square by l square dx. Now integrating this 1 upon 2 ei p square b square by l square, these are constant, p square b square by l square constant, take them outside. Integration of x square is x cube by 3 limit 0 to a plus 1 upon 2 ei p square a square by l square, the constant terms, I and here limits x cube by 3 0 to b. So I can write here 1 upon 2 ei p square b square such that x is equal to a cube by 3l plus 1 upon 2 ei p square a square x is equal to b, so b cube by 3l. Now I can remove some of the common terms. The common terms are for 1 upon 2 ei into 3, so 1 by 6 ei l. Next p square a square b square, p square a square b square, so these are common terms, so I can very easily write p square a square b square by 6 ei into l into bracket a plus b. When I take p square a square b square, here a remains, here b remains, we have a plus b is equal to l. Just look here, a plus b is equal to l. Actually this is l square. So substitute a plus b is equal to l. We have u is equal to p square a square b square by 6 ei into l. This is the strain energy. And what Castigliano's theorem is, delta is dou u by dou p. So I have to differentiate this with respect to p. So differentiating with respect to p, we have delta is equal to 2p a square b square by 6 ei into l, or I can simplify that and write delta is equal to p a square b square by 3 ei l, p a square b square by 6 ei into l, not 6, it is 3, 2 and 3. So this is the final answer, p a square b square by 3 ei l. So this completes one standard problem. Next we will take up a problem on cantilever. Thank you.